2NURFM.com, a broadcast service of the University of Newcastle.
Recently, right across social media and social news, there has been this thing with Siri, Apple's voice assistant. When you ask her to divide 0 by 0, she gets a little bit snarky. So I guess it's what you might imagine might happen with a GPS if you keep turning in the wrong direction. One day I'm expecting my GPS to say, "Wake up, you idiot, why don't you just tell me, why don't you just do what I tell you to do?" It's a similar sort of thing. Michael Rose is from the University of Newcastle School of Mathematics and Physical Science. He joins us this morning to answer the question, why can't you divide 0 by 0? Hi Michael, you've got a nice t-shirt on called Math is Delicious.
Yes, thank you.
It kind of plays into the Siri thing, but why can't you divide 0 by 0?
Okay, so it's one of those questions that I think we've all pondered at some point when we were school kids, and we tried it with the calculator and it just sort of threw a furphy, and now we try it with Siri and it gets a more snarky attitude up. What we have to do is we have to take a different point of view, and then it becomes really obvious. Okay. So I'm going to spend I'll just get us there gently.
I'm grabbing my pencil and getting ready to take notes so I fully understand.
Yeah, there'll be a test at the end of this. So.
Oh, good. You sound just like a math professor. Yes.
Sorry. No, I'm kidding. So, there's 4 basic arithmetic operations that we learn about in school. There's addition, subtraction, multiplication, and division. Yes. And of course there's other things we can do. We can square numbers or cube them or stuff. But that's really just multiplication. It's built out of that. So, okay, so that's our starting point. When you sort of pop the hood, and as it were, and look at how our number system works, what you find is there's really only 2 fundamental operations, which is addition and multiplication. Subtraction and division just sort of at the flip side. Right?
Okay,
you get them
the
for free.
derivatives. If
Yeah, exactly.
Yeah, okay.
And every division problem, if you like, is really just a multiplication question, which is how you learn about it. So, for instance, if I say 6 divided by 2 is what?
3.
Yeah, so I'm looking for, okay, so yeah, awesome, okay, tick. So, okay, why 3? Because I'm looking for a number, right, the one unique number that when I multiply it by 2, I'll get 6. And that happens to be 3. 3 times 2. So, the question of 6 divided by 2 is what? Is really the multiplication problem. What times 2 gives me 6.
Okay, yes, I'm following on, yes.
Right, so and that's how division works. You know, this divided by that means what times that gives this. So, 1 divided by 0 would mean what number times 0 gives me 1.
Ah, okay.
And there's a problem, because of course anything times 0 gives you 0.
That's right, yes.
Right? If you have 0 boxes of 0 cookies, or 1 box of 0 cookies, you have 0 cookies.
Yes, exactly. So, okay.
That's how it works.
So that's okay.
Yeah, so you can't, 1 divided by 0 won't work, neither will 2 or 3 or half or pi or any number you can think of. Except maybe you could go 0 divided by 0. Because that question is asking, 0 divided by 0, what number times 0 gives me 0?
Right.
Okay, but now we have another problem, because now instead of having no answers at all, now anything times 0 gives you 0.
Yes, so you've got the whole multitude of
make it whatever you want. You can make it 1 or 2 or 7 or pi. But there's a problem, because of course if you make it 1 is 0 divided by 0 and 2 is 0 divided by 0, then that would mean 1 was the same as 2, because they were both.
Now I'm starting to glaze over, Michael, but I get the gist of what you're trying to tell me.
You break mathematics if you do it.
Yes, that's right. So dividing 0 just doesn't fit really
into our number system, and that's why, because we have the fact that anything times 0 is 0, you can't divide by 0.
Right, so there you go, folks. If the kids ask you that, just say, it doesn't fit into our number system, and I'm your mother and I said so, or I'm your father, whichever works for you. But there is a system of numbers that you're actually looking at where perhaps this might work, and it's called fractal geometry. Just explain, what is this?
Okay,
Michael?
so, alright. The system, the fractal geometry and division by 0, you can have division by 0 in some contexts, and you can have fractal geometry in those contexts, but they're a little bit separate. What fractal geometry is, believe it or not, a relatively new field of mathematics, so not everything was done millennia ago.
Okay.
This is something that's been researched since the 1970s, and it's basically the shapes of nature.
And this is really interesting. And I was thinking about this when you said that. I remember as a kid going to the beach and looking at the rocks, and they weren't perfect cubes across each other, but there was definitely a pattern.
Yeah.
And it's the same, you might see it in a petal or in the shapes of things in nature. They're not perfect as we know them to be perfect squares or circles,
right,
but there's definitely a perfection in that pattern.
There's something there,
isn't there?
That's it. So yeah, the shapes we learn about in high school, which is called Euclidean geometry, goes back millennia to the Greeks and to Euclid, hence the name, and it's all about triangles and spheres and all of that. With the exception of spheres and perhaps cylinders, there's not too many of those occur naturally. But the shapes that do occur naturally, which we call fractals, all share the same common pattern, which is this. They have a special kind of symmetry.
Okay.
So symmetry in general means something, if you close your eyes and I take this shape and I do something to it, and you open your eyes and you can't tell that I've moved it, right? Like I take a triangle and I rotate it by just the right amount, that's what mathematicians would call a symmetry. Something you do to a shape and it's still the same.
It sounds absolutely fantastic, and
the fractals,
I'm really interested in hearing more about it. We might have to get you back.
Okay, just quickly, the fractals, you can zoom in on them and they'll look the same. That's what makes them special. So you look at a cloud. If I show you a photo I took of a cloud and I ask you, did I take this sort of at ground level looking up, or did I zoom in on a small piece of it? It's impossible to say. And that's fractal geometry in a nutshell.
Excellent. Yeah. So there you go. When you look at nature and you see the pattern and the perfection, there is a recent division of mathematics that can actually explain that to us and why it is so cool.
That's it.
Michael Rose, that is very cool. Thank you. I always thought that math was, a little on the dry side, but when you put it like that, it sounds really great.
In high school maybe, but when you study it, it's beautiful stuff.
Yeah, good on you. A man who's passionate about his math, Michael Rose from the University School of Mathematics and Physical Science. And we might get him back to, do your head in a little more, as fun as that is.